Hi friends. In the last class, we have seen some basic operations in Boolean algebra. Now in this class, we'll try to understand some of the postulates of Boolean algebra because with the help of these postulates only, we can minimize the switching function easily. So let me go through that. Let me write the first postulate of Boolean algebra here. So the first postulate of Boolean algebra is law of intersection. So the name of this postulate is law of intersection. So under this postulate, we have two laws. One is A and 1. A and 1 is equal to A. And the second postulate is A and 0 is equal to 0. If A is the variable and 1 is a fixed value, it is high, logic high, or we can also call it as true. And here A is again is a variable and 0 is a fixed value. When you're making AND operation of A with any variable, means when you make AND operation of A with 1, you'll get the output as A. When you are making AND operation of A with 0, you'll get 0. In place of A, you can consider B, C, whatever is the variable. You'll get the same result. So B and 0, for example, if you take B, B and 0 is equal to 0. Here B and 1 is equal to B. I have taken A for my convenience. Now let me prove you. So by taking the tabular column, so I have two terms here. One is A and another one is 1. Let me show you what is the A and 1, means what is the value of A and 1. If I have only one variable, the possible values are 0 and 1. Now, and it is a fixed value, right? So that's why I'm just copying them as it is for both the combinations of A, for both the possibilities of A. Now, according to logical AND operation, as we have seen in our previous class, 0 and 1 will always give us 0 output, and 1 and 1 always gives us 1 output. Now this A and 1 means the entries in A and 1 looks similar to the entries in A. That's why I can say A and 1 is equal to A. Let me come to this postulate. Let me show you. Here there are two terms. One is A and another one is 0. Let me show you what is A and 0 for both the possibilities of A. What are the two possibilities of A? One is 0, another one is 1. Now this variable I am just copying as it is because it is a fixed value. Now 0 and 0, according to AND operation, 0 and 0 always gives us 0. 1 and 0 always gives us 0. Now, as you have observed from this entry, from this column of this table, whatever may be the value of A, that 0 or 1, it is always giving 0 output. That's why I can say A and 0 is 0. This is the law of intersection. Let me show you second law, which is law of identity. So the second law name is law of identity. Law of identity. It also has two postulates. One is A plus 1, means I can call it as, actually I need to call it as A or 1, and it is equal to 1. Similarly, the second thing is A or 0 is equal to A. Let me prove this postulates by taking the table again, similar to the previous law, which is law of intersection. So I'm taking two entries. One is for A and another one is for 1. Let me show what is A plus 1 value, right? When A is the only variable, the two possibilities are 0 and 1, and I'm just copying 1 as it is. Now, according to logical OR operation, 0 plus 1 or 0 or 1 will gives you high output, and 1 or 1 means 1 plus 1 again gives you high output. Now, by seeing the third column or these entries, the entries of third column, you can say that whatever may be the value of A, either 0 or 1, it always gives us high output. Let me come to the second postulate. So this is A, and I need to have one more entry for 0, and I need to check what are the values of A or 0 or A plus 0. What are the possibilities for A, 1 and 0? I am just copying 0 as it is. Now A plus 0, which is 1 plus 0. In logical OR operation, if any one of the input is high, automatically output is high. If both the inputs are low, the output is low. Now, by seeing the third column and the first column, you can say that both are having the same entries, A and A plus 0. That's why I can say that A plus 0 is equal to A. This is a second basic law in Boolean algebra. We can call them as laws of Boolean algebra or postulates of Boolean algebra. Next one is law of idempotency. Law of idempotency. Idempotency. Now, in this law, we have two sub laws. First one is A plus A is equal to A, and the second one is A into A is equal to A. Okay. So here I can consider two columns again, A and A, and I need to check for A plus A. If A is 0 and A can be either 0 or 1. So this entry must also have this column must also have the same entries, because I am considering A values two times in order to perform logical OR operation according to this law, right? Now 0 plus 0 or 0 or 0. If both are low, the output is low. If both are high, the output is high. So A plus A column looks like A. That's why I can consider like this. Similarly, you can do AND operation for A and A. So A and A. The possibilities for A are 0 and 1. So you here also you must get the same values. Now 0 and 0. According to logical AND operation, if both the inputs are low, output is low. And in logical AND operation, if both inputs are high, the output is high. Again, this column looks similar to both these columns. That's why I can say A and A is equal to A. This is the third law. Let me show you the fourth law, and it is the last law of our today's class, which is law of complements. This law, the name of this law is called as law of complements. According to this law, if you make the OR operation with means OR operation between A and A bar, you will get one output. Similarly, according to the same law, if you perform AND operation between A and A bar, the output will be 0. Okay. Now, how can you do it? Make two entries for A and A bar, and the third entry for finding A plus A bar value. If you have only one variable, the possibilities are 0 and 1. Now, here I am complementing it. A bar is nothing but complement of A. Here I am complementing it. If A is 0, A complement is 1. If A is 1, A complement is 0. Now you need to perform OR operation between these two variables. According to logical OR, if any one input is high, the output is high. Now you can observe from the entry of third column, A plus A bar is giving one output irrespective of A value. This is proved. Let me prove the next one, which is A bar, A and A bar. If A value is 0 and A value is 1, if A value is 0, what is A complement? 1. If A value is 1, A complement is 0. Now perform the logical AND operation between these two. If you perform logical AND operation, in logical AND operation, if any one of the input is logic low, the output is low. That's why you will get 0 for both the entries. Now, whatever may be the value of A and A bar is always giving 0 value. Here, whatever may be the value of A A plus A bar is always giving one value. These are the four basic postulates of Boolean algebra. So I want to stop here. In the next class, we will see some more postulates. Thank you very much.